everyone. I hope you enjoyed Alex's talk this morning and that you're all excited about Black Hat today. And one of the points in his talk was we need to figure out how to balance attack and defense. And with that in mind, I'd like to talk about how to do that for a particular topic. It's one of my topics of specialty, phishing. So let's talk a bit about who I am to begin with. I'm a security engineer at Stripe, but my background is actually in offensive security. So I've hacked train ticketing systems, I've written about SSL vulnerabilities, and I've actually competed in the DEF CON CTF finals for the last couple of years running. Internal phishing protection, so phishing protection of our employees, is actually a side project for me at Stripe, but kind of scarily, it's been pretty successful in my experience. I've phished over half the company in the course of my different tests. So let's chat a little bit about phishing. There's a lot of targets here and a lot of actors, and we see lots of different types of attacks. In 2011, we saw the RSA master key phishing, where they used social media and a flash malware exploit in Excel to compromise the SecurID 2FA database. That's the database behind those RSA tokens. In 2014, we saw ICANN lose control of the centralized data systems, which controls domain name registration through spear phishing. And also in 2014, we saw Sony hacked by apparently North Korea because they had their Apple ID emails stolen. And so that's a pretty broad space, and I'd like to kind of narrow down specifically what I'm going to be talking about. So for this talk, I'm only going to cover cases where you control the platforms of the people being targeted. So this typically means I'm talking about your employees rather than your users. And I'm also going to cover targeted attacks. I'm not going to talk about like the emails that get sent out to thousands of companies and maybe one employee falls for it. We're going to talk about sophisticated attacks that are actually focused on your particular company. And we're going to do this in 3 sections. Our first section will be the psychology of phishing. Then we're going to talk about the story of phishing at Stripe, the different campaigns we ran and what was and wasn't successful. And finally, I'm going to cover how you can prevent phishing at your company or particular types of it. But to begin with, let's talk psychology. This is kind of your standard phishing email, right? A Nigerian prince wants to offer you an extremely large sum of money if you just hand over your bank details. And these type of emails make attackers and defenders really lazy. Attackers get told, you can't use phishing in your red teams because it's too easy. And defenders get told, well, provided you train your users, they won't do this and it'll be fine. But that's dangerous and unrealistic. Just because you say that phishing is inevitable doesn't actually make the problem go away. And it also encourages a really us and them mentality. You know, we are the security engineers, we would never fall for this. And they're just like the non-technical users who don't know what they're doing. So rather than splitting this up, I want to talk about why people fall for phishing campaigns in the first place. Daniel Kahneman wrote a really interesting book about psychology in general, in which he posits that there's actually 2 modes of thinking we have, System 1 and System 2. And he calls this the fast and slow mode, basically. System 1 is what you use when you see a car ahead of you stop suddenly on the freeway and you swerve or brake without even thinking about it. It's very fast and it's very instinctive. It's below what we consider to be the level of conscious thought. But it's also pretty emotional and pretty gullible. System 2, on the other hand, is a much slower and more methodical method of thinking. If you've ever written up a list of pros and cons for some kind of business decision, you are using your System 2 brain. It's rational and it's skeptical. But the problem is, we don't usually have enough time in our days to use System 2 everywhere. We use System 1 for decisions that we consider to be unimportant and that can be solved easily through pattern matching, which is typically how System 1 operates. But I want you to stop and think for a second about how much email you receive in a single day. I don't know about you, but I get at least 100 emails a day. I don't have time to be sitting there and thinking about whether or not they're legitimate for every single email. That's System 2 processing, and there just isn't the time for it in the day. And the problem we have with phishing training at the moment is that it's focused on training people to look at URLs or hover over links, but all of those are System 2 methods of thinking, not System 1. Phishing training is only useful when someone is already suspicious of the email, not beforehand. And you can't train someone's System 1 to think that one email is suspicious when it looks exactly like every other email they've received from a service. And it doesn't matter how technical you are, this applies to all of us. Everyone is vulnerable to this. So rather than splitting up different types of phishing based on who's being targeted, so spear phishing would be one particular person and whaling would be a particular person who's a CEO, for example, I instead want to split it up based on the attack vector being used, because that informs the sort of defenses we need to have in place. So I'd like to choose 3 different types of phishing. The first is action-based phishing. This is where you phish for something that's valuable in and of itself. So if you email a finance team and convince them to wire several $1 million offshore, you probably don't need more than that. That's kind of your end goal. That's action-based phishing. Exploit-based phishing is the sort of thing we heard about with the RSA keys, where flash malware was used to get access to them. In that case, you're trying to get code execution on a particular machine and use that to pivot to more access. That's exploit-based phishing. And finally, there's this concept of credential-based phishing. So you're phishing for access to usernames and passwords that aren't in and of themselves valuable, but that allow you to pivot to more valuable credentials. So in this case, you might email a user and ask them to type their password into a phishing site. And as I said, each of these different attack vectors has different defenses. For action-based phishing, we can put in place controls that require that multiple users sign off on dangerous actions. For exploit-based phishing, we can mandate that certain software can't be installed on a machine because it's too dangerous, or that you need to have updates installed as of this date. But we don't really have a good solution for credential-based phishing. We say, oh, we'll train our users, and then they won't click on links, hopefully. That's not actually that effective, though. So that's the type of phishing I'm going to focus on for this talk. Just as a brief recap, this is usually how credential-based phishing works. You send some kind of hook email, doesn't seem at all out of the ordinary, looks just like a normal email from the service, but also contains some type of call to action. Then, when the user clicks the link, they're sent to a phishing site, which looks similar to the original, typically a similar domain, hopefully cloned from the original page, maybe hosted on HTTPS. You steal their credentials, and then you have some kind of trail out, because you need to convince the user at the end of all of this that everything is completely normal. Credential phishing is useless if someone realizes immediately after the fact and rolls their credentials. So in this case, you might want to redirect back to the original site or have some kind of action succeeded message. And now that we've recapped the general format of this, I'm going to show you 2 emails, and I want you to try to figure out which one is legitimate and which one isn't. Here's our first email. This is a real-world example of a campaign that I ran at Stripe. Cool, and here's our second email. And just to put them side by side so it's nice and easy to compare, here's both of them together. I want you to sit and think to yourself which one you think is real. Both of them are sent from noreply@slack.com. Neither of them contain any spelling mistakes. They both have a call to action. In this case, the left one is real and the right one is fake, but there's actually not enough information on this slide for you to be able to tell that. As I said, they're both sent from the same email address. They both have calls to action. And short of knowing exactly what emails Slack sends, there's no way for you to verify which is correct and which isn't. I actually had to get this email approved by our VP of engineering before I could send it to everyone at the company. And I sent it to him and said, hey, I'm sending you a phishing email. And he clicked on the link and went, wait. People who know what they're doing fall for this stuff. In this case, we actually had pretty poor conversion on the overall campaign because I built this in a day. I didn't have time to set up HTTPS on the website. And people look for that. People have been trained to look for the green lock. But the green lock does not mean it is not phishing. It means someone knows how to run Let's Encrypt. So let's talk about the next campaign I ran. This was several months later. And I thought, well, I had Slack access, but wouldn't it be great to have code execution on our production machines? GitHub is a pretty easy way to pivot to that. And so I thought, well, I'll send out a GitHub campaign. In this case, the message that's being shown here is legitimate, but the email itself actually isn't. GitHub sent plain text transactional emails, and this led us to a really interesting point. Should we send this phishing campaign in plain text or in HTML, right? Should we match the existing emails from the service, or should we try to make it as pretty as possible? Usually you see better conversion for pretty things, and that's why marketing emails are all shiny. So I did some science. I sent half of the emails in plain text and half of them in HTML, and I went, which one has higher conversion? We saw about 10% conversion on the plain text email and closer to 50% conversion on the HTML one, even though these emails looked nothing like the emails that GitHub actually send. In this case, you just had to match the general look of the website. You might also have noticed that the previous slide had a public key fingerprint in it. Lots of people told me that they thought it was legitimate because the public key fingerprint was correct. But your public keys are public in GitHub's API. You can generate those fingerprints yourself. This is actually the phishing page that I then proceeded to host. As you can see, they look basically identical. Helpfully, at the time, GitHub had some configuration that meant a missing subdomain.github.com would redirect to missing subdomain.github.io, which is actually user-hosted content. That's GitHub pages. So funnily enough, the right-hand picture here, the phishing campaign, is actually being hosted on GitHub's own infrastructure. This campaign cost me absolutely nothing. It's also using their SSL certificates. But the problem is you don't necessarily know that, right? Like, GitHub.io isn't clearly not a domain that GitHub's in control of. And this really highlights that you shouldn't host user content on domains that aren't obviously user content hosting. The other thing I did here was I set up a bunch of analytics because I wanted to understand how users interact with phishing pages. So I tracked page opens, keystrokes, and form submissions. The interesting thing we learned with this was, although we installed password managers on all of our employees' machines, about half of them had typed their passwords in by hand. But more concerningly, half of them had copy-pasted their passwords into the fields. That means they used a browser extension that tells them that the website's not legitimate, and they'd gone, it's probably not working. I should just copy-paste my credentials in anyway. Users don't actually trust password managers to actually do domain verification correctly. And that's a problem because you can understand why. How often have you seen 1Password say, I'm not really sure if Chrome's legit anymore because it's auto-updated, so you're on your own. That's the sort of thing that's really dangerous for users. Just for completeness' sake, this was the trail-out page for this campaign. You can see it's hosted on real GitHub, and the keys that you would see here would match the keys that you saw in the email I sent. So further collaborating the idea that this is a legitimate email. And it's about here that people start to mention two-factor authentication to me. They say, oh, well, it's great that you're phishing for things, but I have two-factor auth on, so all of my users are protected. And then I'll say, well, okay, but if you use Google Authenticator, so TOTP-based 2FA, I can just steal that just as easily. I'll only be able to log in once, but so what? And then they'll say, well, okay, I use SMS 2FA. You won't know my phone number. But that's a problem because I can just proxy a login request to the real service and have it send you a text message and then steal that credential. 2FA credentials can be phished just as easily as usernames and passwords. They just only give you a single login. And this is because two-factor authentication, while it's valuable, it's not actually designed to solve this problem. It's designed to solve the problem of shared credentials across multiple sites or password dumps. It's not designed to help with phishing. It's only incidentally making it a little bit harder. So at this point, I was kind of thinking, well, so far I'm not really convinced by the value of the training we've been doing. Right? We've been training our users and they've been ignoring the things we tell them, like don't ignore your password manager. So I wanted to do even more science. So I thought what I'll do is I'll do some phishing training and I'll show a phishing page. Then, several months later, I'll send out that same phishing page and see just how many people catch it. And we'll use that to determine how effective our training was. So our phishing training is actually quite interactive. It's similar to what we've done here today. We show you several websites and we say, do you think this one's legitimate? This one's fake? Then we talk about how you could have identified that one was or wasn't legitimate. In this case, I showed this page, which is the AWS IAM login page, and said, we've always talked about how you need to look at URLs, but it's pretty difficult to tell this one's legitimate. It's long, it's complicated, it doesn't have obvious indicators that it belongs to Amazon. And the lesson we were trying to get across here is, complicated URLs are easy to phish. Be careful and trust your password manager. Then 3 months later, I sent out this campaign. Again, the top one here is legitimate and the bottom one is fake. I spoofed an email from the head of our security team and I used a Gmail bug to bypass the SPF and DKIM protection we would normally have on our domains. These are things that prevent unauthorized senders of email from actually pretending to be you. And in this case, I explained the lack of a password manager filling in the email by just saying it was a beta product, so don't worry about it too much. And this campaign phished for not just passwords, but also two-factor authentication credentials, just to demonstrate that users would type them in. Of the emails we sent, assuming that you opened the email, 40% of people clicked through. Assuming you saw this page, 2/3 of users entered their credentials. So that's an end-to-end conversion rate of 1 in 4. I sent this to every engineer at the company. It's pretty terrifying, right? If you can get enough people to give you these credentials, you can get complete code execution on our servers. We're talking administrative access here. And those people who were phished, they included 2 of my friends who helped me build the campaign. They didn't know exactly what it was going to look like, but they knew that I was sending something kind of suspicious looking out in the next week or so. One of them actually entered their full set of credentials, and the other one made it to their password manager not actually saying the correct thing, and DM'd me saying, haha, I don't owe you $20 this time. So what do we do now, right? We've talked about some of the different protections we have, but we've said that they're all kind of vulnerable. We've talked about how you could use SPF and DKIM to prevent unauthenticated senders from spoofing email from your domain. We've talked about how you can encourage the use of password managers, but users kind of ignore it. The issue with SPF, by the way, is that clients have to validate it, so if anyone's using a desktop email client, it's basically fair game. We've said that you can mandate 2FA, but that also is only incidentally helping. I'm all for realistic over perfect, but each of these different mitigations is really easily bypassed. And this has led to this sense of hopelessness among the security community. People will be phished, there's no point red teaming for phishing because of course you can get in that way. And that's really dangerous, because even if you have detection on your users' activities, you probably can't respond fast enough. Even with, say, a 15-minute SLA to a pager, you're probably not going to be able to stop someone from leaking valuable information or pivoting to yet another service. And now you're racing a clock to try and catch up to where they are. And also, just because I can only log in once doesn't mean that I can't find other ways to get into your service. OAuth and application passwords in email clients provide really excellent ways of hiding the fact that I still have the ability to access your data. And all of this only requires a motivated attacker. None of these are technically difficult. Any software engineer could do this if they wanted to. And the underlying issue here is that any protection that relies on a human being making a reasonable decision is going to fail. People can be tricked. People like to trust others. You need to find technical solutions to this problem rather than just saying, we'll train people and everything will be fine. So let's kind of take a step back and go back to the beginning of authentication. We're going to talk about the 3 different types of authentication factors. These are what's referred to when you talk about 2-factor authentication. The first is something you have, so this is something you physically possess. For example, 2-factor authentication phone apps. The second is something you know, typically your password. And the third is something you are, so biometric data. On the internet, we mostly tend to use know, and for more secure services have, because biometric data is not really a standardized API on the web yet, so it's kind of the only option we have. And if we want our users to be safe, even when they try to give their credentials away, we need to tie these factors to the domain that's requesting the information, rather than just giving them out as if they're shared secrets. So at Stripe, we started doing this using SSL client certificates. These are the client equivalent of the server certificates you use over HTTPS. So the server requests a certificate, and the user's machine serves it up. They're kind of like cookies, but without all the downsides of cookies in that they're not a single shared secret being passed around everywhere. They actually use public-private key crypto, and the secret stays on your machine. They're a super great user experience because you don't even know that you're sending them most of the time. And they're pretty difficult to unintentionally leak because you have to go digging around in your computer's trust store. I think even the most, like, I'm great at everything software engineer is probably going to think twice before sending that to a random person. But the problem with client certificates is that they're similar to a password, and they're long-lived, right? Access to a client certificate ever means that you've lost access to that service. What we really want here is the same type of one-timeness that 2-factor authentication gives us. We want the leak of one credential to not be sufficient. And ideally, this second factor is going to need to have some cryptography as well, because otherwise it can be phished. Luckily, there's a protocol for this. It's called U2F. It was released a couple of years ago. And essentially the idea here is that you provide a security key, so a USB device, that itself is a second factor of authentication. The way it works is when I go to a page that uses U2F authentication, the service generates a challenge, and my browser sends down the challenge and the domain that's requesting the challenge. The security key signs a response to it using a private key that's just on the chip itself. And it signs a response that includes both the domain and the challenge. So this means the credential it generates is only valid for the domain that asked for it. What this means is even if I manage to convince a user to tap on their key, which is super easy, it doesn't actually help because they've generated a secret that's valid on evil.com, but not good.com. When I try to pass it through as an attacker, it won't validate. Helpfully, a couple of services have started adding support for this. We see Google, Dropbox, Facebook, and actually Stripe working on this. And Google, in fact, if you run a Google Apps domain, allows mandating this as the only form of 2FA, which prevents your users from being phished there at all. Intel are also building support for this into their chips that are going to be released later this year. So specifically what that would mean is you wouldn't even need an external device. You just have it built into the chip that you're running on your machine yourself. But the problem is it's only supported by a couple of different services, right? And we need to protect everything. So at Stripe, we solve this problem by using single sign-on. Essentially, single sign-on allows one service to delegate authentication to another. And so what we did here was we had each of the different services we use delegate to an internal authentication provider we have that validates client certificates and a U2F credential on a regular basis. And this is really cool because it means we can protect any service that supports SSO. And SSO is a pretty old technology, so most of them do. Unfortunately, it's not a panacea. There are a lot of problems with U2F because it's just getting started. The most notable is that it doesn't actually support mobile authentication super well. A small number of services do, but at the moment you realistically have to provide a fallback for most users, which means that you can still convince someone to type in a TOTP or SMS credential. We are working on this, it is getting there, but it's hoped that in the meantime, at least someone would think twice before having to go and grab their phone rather than their USB. And the other problem with U2F is that it only protects authentication flows that actually ask for credentials. How many of you remember that Google Docs worm from a couple of months ago? You got an email from hhh@mailinator.com inviting you to a Google Doc and asking for access to all of your email. Luckily, this worm wasn't malicious. It just wanted to spread because it was some kind of script kiddie. But interestingly enough for us, Stripe wasn't affected by this attack at all because I ran the same one a year earlier. This is the email I sent. At the time, we were using a document management service called Quip, just like Google Docs, slightly different. I actually thought this would be a little too cliched. It's an email from the CEO talking about compensation adjustments, but it turns out everyone really likes to know how much they're paid, so they all clicked through anyway. And I also thought the sender of the email would give it away, because Quip had SPF and DKIM enabled, so I just had to register some other random domain that looked similar. If you clicked through, this is the prompt you would see. It would be hosted on accounts.google.com, just like you'd imagine. And if you look here, the only way for you to tell that it wasn't legitimate was to click on the name of the application and see that the developer was registered to my email address. If I'd wanted it to look more plausible, I'd have registered it to the fake domain I had, but I didn't want people to freak out too much. And so in this case, we saw, honestly, really terrible conversion rates. If you think of how successful the Google Docs worm was, and remember that it was sent to hhh@mailinator.com and was BCCing you, given that you opened the email, we saw an end-to-end conversion rate of 80% on this. That's 80% of our employees granting access to this application. So we actually protected this using the whitelisted domain controls that Google have recently made public. And what this meant was on the day that the Google Docs worm happened, our security team was sitting around at lunch going, "This is great. Let us know if we need to help with your personal accounts." But just to reiterate the fact that everyone's vulnerable to this, I had a friend on the security team helping me build this. I asked ahead of time, is it unethical for me to fish for OAuth credentials? And can you invite me to a document from our document sharing service? Then a couple of days later, I sent him an email and I said, hey, let me know what you think of the phishing email I sent you. I did it pretty late at night, so I waited till the following day, gave him a couple more hours. It's like the end of the following business day, and I'm like, hey, like it's a phishing email. It takes 5 minutes to read it, right? What do you think? I didn't get the email. It took me 3 goes of telling him the subject before he figured out what had happened. He'd clicked on the link, he'd seen the permissions, and he was in the process of writing a nasty email to the service provider asking why they were asking for these permissions. This is knowing exactly the campaign I'm going to send. So this is something that can happen to everyone, right? Let's wrap up. A well-crafted phishing attack poses a real danger to all organizations, and banning them from red team exercises ignores one scary problem to focus on others, but doesn't actually get rid of the problem in the first place. Phishing training is only going to help users in a pretty limited set of scenarios, those emails with spelling mistakes or that aren't really targeting you, but it's not actually going to help for someone who's trying to get into your company. But luckily, it is actually possible to protect your users without them knowing that you're doing it. And you should do so, because otherwise you're doing everyone a disservice. Because the biggest thing for you to remember out of this talk is that anyone can fall for phishing, because in the end, we're all human. Questions?